again to our online mathematics class. And today we want to look at another aspect in mathematics, which we call equation. But in our last class, the last two lectures we discussed indices, and we were able to justify the laws of indices, and we were able to look at the inverse function of indices, which is the logarithm, and we're able to look at it from that angle. Now, but we mentioned something about expression and equation, and what determines that is the use of it, that is when you have equal to sign in between some of differences of terms. That's when you have equation, equal to sign. It's very, very vital. So what makes an equation? An equation is what? Is equal to sign. So, but I want to pick it from this angle, that what are the types of equation that we have? We have linear equation, we have quadratic equation, we have cubic equation, and we have quartic equation, and generally we have what we refer to as what? Polynomial equation. But because of this name in mathematics, take note of that, nomia, is so vital. So that will make me to expatiate a little bit on the concept of this equation so that you can understand where they are coming from. You remember vividly that your linear equation is of this form. This is the general equation of the linear equation. Can you remember? So in this case, ignoring if y is 0, you have mx plus c. Then, how many terms do we have here? 1, 2. Then, we call this one binomial. Nomial means in mathematics the number of terms. So if it is 2, we have binomial. If it is 3, we have what? Multinomial. So from this class, you can say this one is what? We call it what? Bi. Bi means what? 2. Binomial concept. Then all others, we can generally call all these, we can call them what? Multi. You know, multi means many. Multinomial. Or from the name here, when we refer to as what? Or this one called polynomial. Can you see that? So, you know, multiple times. For instance, quadratic, we have of this form. Y equals what? Ax squared plus, what's that? Plus bx plus c. Can you see? 1, 2, 3. So we have this one to be what? Trinomial. It still has its own family name. Trinomial. Can you see this concept? So for cubic, then you know you are going to have what? 4. So that it has the raised to power of what? 3. So this one is can to continue. So that's why we call them generally multinomial or polynomial. But I want to now let you understand some concept that polynomial is a general family of every equation. All equation comes from this. How? Okay. You remember this? Anxn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2, can you see? Plus dot dot dot. This, we call this ellipses in mathematics. It shows that there are terms in between. Then we can have what? A naught, x0 for instance. Let's put this, we call this one equation. This is what you remember. This is polynomial equation. Why? Because you have how many times? N. You understand? So we call this one what? N degrees of polynomial. Degrees of polynomial. Because we have what? Can you say n? This is n degree of polynomial. So from this, you can easily obtain any of these class of equation from here. Comfortably. How? Let me justify for one or two so that we'll be able to move on as fast as possible. Okay. Let my n, the degree, be equal to 1. That's what we are going to have. This one becomes what? A1 x raised to the power 1 plus A1 minus 1 x raised to the power 1 minus 1. You can't have the subscript of negative, so you stop it immediately and equals what? 0. Therefore, this one becomes what? AX plus what? A0 x 0, which is equal to what? 0. Anything raised to the power 0 is equal to what? It's 1. So AX plus what? A0 equals what? 0. Can you observe this? That it looks like this family, mx plus c equals 0. Can you see? So we obtain our linear equation from the what? The general terms of polynomial. Can you see? Very interesting. So this is your linear, where a equals to m, x is the x, then a0 equals what? Equals c. That's the first one. So let me still show you one more, and you see how we obtain quadratic equation, which is what we are called trinomial, from that same polynomial parameter. Okay, so in that case, what are you going to have? N must be equal to what? Let n equals what? 2. Degree 2. Take note of that. So we can have what? A2x squared plus A2 minus 1 x2 minus 1 plus A2 minus 2 x2 minus 2. Can you see? We must stop there. Equals what? 0. You can't have negative. So we can have this one to what? A2x squared plus what? A1 x1 plus what? A0. Because this one will be raised to power 1, which was 0. Can you see? Comparing this with this, then we can have what? Ax squared plus what? Bx plus what? C equals 0. Can you see? This is quadratic, which is what? Trinomial. 3 terms in that kind of equation. If you continue, the next one must be what? Power of 3, which is cubic. The next one is what? Quartic. And until you continue, there is another name we can call the one of power raised to power 5 or whatever, then you get the concept very well. So now, here we'll now begin to pick these equations and argue them one after the other, so that you can see the way you solve problems of equation in mathematics. Okay. So the first one we pick is what's the linear equation. And we are told that it's of this form, y equals what? Mx plus c. Take note of something here. If y is 0, if y is 0, therefore what are you going to have? You're going to have ms plus c equals 0. That's all. Take note of that. And don't forget when, so now let me now talk about how you can solve this. Let me tell you the implication of this. For known value of x, x is an independent variable. Y is the dependent variable. For known value of x, we can obtain this. M and C, they are what? Constant. Take note. M and C are constant. They are not changing. So in this kind of equation, you can either solve for x for known value of y. And for instance, you can solve this one what? Maybe normal mathematical operation, general mathematical operation, general mathematical operation. What do I mean by that? I will explain. By maybe make x subject of formula from here. That's what I mean by that. Then you can also obtain what? Graphical solution of that. Graphical solution. So for instance here, if you plot the graph, you will generate values of x and y. And you plot in the graph. You must have a straight line graph. How does it look like? Look at it. Straight line graph look like this in mathematics. It might pass from the origin, this y has this x has this. So you are possibly having a graph going this way. So that the one, take note, this will be your what? Your C. That's your intercept. Okay. So you now obtain your m using this, which m is called what? That's the slope of the graph. So slope or gradient, I see, equals what? Equals m, which is what we are saying here. Change in y, permit me to use this one. Change in y or change in what? In x. So that's what we refer to our change in y over change in x. Which is the same thing as what? y2 minus y1 divided by what? x2 minus what? x1. That's how we determine the parameter of m and c. Can you see? This c and this is what? This is your m parameter. Good. That's how to solve using the graphical method. Why the general method I told you is what? You just collect like times from here. What do you have? You have x will be equal to what? Minus c over what? Over m. Successfully, just listen to that. So you go back and substitute for x here in order to solve normally. So that's the normal linear equation. Okay, let us look at a problem, y problem in that area. That you can come across linear equation problem. How does it look like? If you remember your simplification concept. For instance, what is that kind of problem? This is WAEC 2017. You have to solve the equation. Solve the equation. The equation 2 into 2x minus 5 divided by 3 minus 3 into 2x minus 3 divided by what? 5 equals what? 3. Oh, this is WAEC problem. Can you imagine that? Look at this. Look at the concept. So what does that imply? It is linear. Why is it linear? Because you observe these x's. Don't let it doesn't change. It's a power of 1. Okay, so it means that y equals to 3. That's the meaning. That's why it's linear. So why do you solve this problem? Well, just bring in, collect like times here. You can maybe write it here. 2, let's expand the bracket. That's 4x minus what? 10 divided by what? 3 minus what? 6x. Be careful there. Be careful there. Plus what? That's minus 9. You know, this negative is not affecting it yet. Be careful, because it will affect your answer. Equals what? 3. So what do? Let's find SM. SM is what? 15, right? 3 here, that's 5. Multiplied by this, that's 20x. What's that? Minus, we are using 5, that's 50. Then, this one must affect the bracket now. 5 here, 3. 3 times it gives us what? 18. That's minus 18x. Then, what do we have? 3. Minus times minus gives us plus. Take note of that. Then 3 multiplied by that will give us 27. Equals what? 3 over 1. So you can resolve this one to become 20 minus this will give us what? 2x. Minus 50 plus 27 will give us what? That's like 23. Right? Divided by what? 15 equals 3 over 1. What do you do here? You cross multiply. This one takes here, you have 2x minus 23 equals 15 multiplied by 3, that should be 45. Right? Good. Then collect like times you have what? 2x minus 23 equals what? 45. Then 2s will be equal to what? 45 plus what? 23. Then 2s will be equal to what? 8. That's 6, right? Then we can have s to be equal to 2 here, 3. Then 2 here, 4, 34. And that's how you solve that problem. It's a simple problem on linear equation. Why these problems like this? And next class we'll see how you combine two linear equations together. When you have two linear equations of this form, y1 equals mx1 plus c, y2 equals mx2 plus c. This gives us what? Simultaneous equation. That's all. And in our next class, we look at how you solve problem on simultaneous equation. And you also remember we've done indices, logarithm. Then after simultaneous equation, we will solve an advanced level program that covers the 3 topics. It will be very interesting. Thank you very much.